In the world of data analytics, we're all constantly chasing one thing: speed. We want our queries faster, our insights sooner. So today, we're going to pull back the curtain on a really clever technique Vertica uses to get some seriously impressive performance. And here's a hint. It's not about buying bigger, faster hardware. It's about being smarter with the data itself. Okay, let's get into it.
I mean, this is the big question, isn't it? You've got these massive data sets, terabytes, maybe even petabytes. And just throwing more money at faster hardware, well, that doesn't scale forever, and it's definitely not cheap. So the real challenge is, how do you work smarter, not just harder, to get the speed you need?
And here it is. This is the key idea for our whole discussion today. The secret sauce isn't just about making the data smaller, which is what we usually think of as compression. It's about something different, a process called encoding. And that distinction, while it might seem subtle, is absolutely critical for performance.
So here's how we're going to break this down. First, we'll nail down what encoding actually is and how it's different. Then, we'll look at the specific strategies Vertica has in its toolkit. After that, we'll get into the fun stuff, how you can actually unlock maximum efficiency. And finally, we'll talk about the performance trade-off, because, there's no free lunch.
All right, let's start at square one. What in the world are we talking about when we say Vertica encodes data? The best way to think about it is like teaching your data to speak the database's own native language, its preferred dialect.
Now, if there's one word to burn into your brain from this slide, it's directly. That is the whole magic trick. See, with normal compression, you have to stop and decompress the data, unzip it, before you can do anything with it. But with encoding, the query engine can work on the data as is, instantly. It just skips that whole extra, very costly step.
And this chart lays it out perfectly. Look, compression is fantastic for saving disk space. We all use it, but it always comes with that performance penalty of decompressing it later. Encoding, on the other hand, is built for speed. By converting data into a format the engine can read natively, you save a ton on disk I/O and memory bandwidth. And in massive parallel systems, those are almost always your biggest bottlenecks. I absolutely love this analogy. It just clicks. Think about it. Traditional storage is like writing out every single word in a book. Compression might be like just writing in a smaller font. But encoding is like using a well-understood shorthand. The database doesn't need to translate it back into long sentences, it just reads the shorthand directly. And obviously, that's way, way faster.
Okay, so we've got the what and the why. Now let's dig into the how. Encoding isn't just one thing. It's a whole toolkit of different specialized algorithms. And picking the right tool for the job really depends on the kind of data you're working with.
So here are the heavy hitters. You've got run-length encoding, RLE, which is just a monster for columns that have very few unique values, especially if they're sorted. So instead of storing Canada a million times in a row, it basically just stores Canada and the number 1 million. Super efficient. Then you have clever ones like delta value, great for timestamps, where it just stores the change from one value to the next. And there are others like block dictionary and common delta for different kinds of data patterns.
Now, this might seem like a lot to keep track of, but here's the good news. You don't have to be a world-class expert on all of these. The default setting is simply auto. Vertica just takes a look at your data, analyzes its properties, and automatically picks the best encoding strategy for you. It's pretty brilliant, really. The system does the hard work for you. All right, so the system is smart, but we can make it even smarter. How do we, as the designers of the database, set our data up for success? How do we squeeze every last drop of performance out of this? This is where our physical design choices become so important. If you remember one thing from this entire explainer, please let it be this. The single biggest impact you can have on encoding performance is how your data is physically sorted on disk. It's everything, because sorting is what groups identical values together, and that's the perfect setup for these encoding algorithms to do their best work.
And here's the simple playbook. You take those columns that have very few unique values, what we call low cardinality columns, like country or gender, and you put them first in your sort order. When you do that, you create these long, beautiful runs of identical data. All the values for France are next to each other. All the male values are next to each other. And that just lets run-length encoding go to town. The performance boost can be absolutely massive.
Now, besides sort order, a few other things can help. You should definitely use Vertica's Database Designer tool. It samples your data and gives you great recommendations. Choosing the right data types also matters. Sometimes a numeric type encodes better than a float, for example. And just be aware that things like character sets can sometimes affect the size of your string data behind the scenes.
Okay, so far encoding seems like pure magic, right?
A free performance boost with no catch. Well, like with pretty much everything in tech, it's not quite that simple. There's always a trade-off, and it's a really important one to understand.
And there it is, plain and simple. All this amazing work of encoding and operating on that encoded data, it still takes some processing power. It's not a lot, but it's not zero. So what we're really doing is we're making a trade. We're spending a few CPU cycles to save a whole lot of I/O and memory.
So when does this trade actually matter? Well, for the vast majority of big data systems, your bottleneck is I/O. You're just waiting around for the disks to spin and feed you data. In that world, encoding is a slam dunk, a huge win. But in the rare case that your system is CPU-bound, meaning your processors are already running at 100%, then the tiny bit of extra work from encoding could become a problem. It's a balancing act, but it's one that almost always comes down on the side of encoding. And really, that's the question you have to ask yourself when you're designing and tuning your systems. You have to know your bottleneck. Is your system spending all its time waiting on I/O, or is the CPU the thing that's holding you back?
And that kind of leads us to the final big idea here. Encoding is an incredibly powerful tool for crushing I/O bottlenecks. But as our data pipelines get more and more complex, it forces us to step back and ask that bigger question. Are we even sure we're optimizing for the right thing? Knowing where your real constraints are, that's what separates a good data architecture from a truly great one.